All right, guys, so let's talk about probability. Fundamentals of probability, very basic stuff. So, probability is the chance that an event occurs based on known information. There are two types of probability, theoretical and empirical. Theoretical probability comes from known information, like how many sides are on a quarter, how many kings are in a deck of cards, things like that. Empirical probability comes from data or experiments from real life. Would be, how many teenage boys had a total loss accident in 2019, okay, things like that. So we're going to, and really the definitions are pretty much the same, and pretty much these concepts are going to be parallel to each other. Most of what we're going to do is going to be theoretical probability, and you'll see how that spills into empirical probability. Okay? So, let's start with the definition. The probability that an event occurs is the number of ways that that event can occur divided by the total possible number of outcomes. And I will repeat that definition over and over and over. If you know that definition and you understand the counting methods from earlier in this class, you can answer any probability question. They're very, very, very simple questions, okay? Empirical probability is going to be the same thing, except instead of saying how many ways something can occur, we're going to say how many times it has occurred, divided by the total number of observations, okay? So, let's go ahead and try a few. But before we do that, let's talk about a couple of really important facts. Number one, probability should always start as a fraction. Why? Because the definition is a fraction. So in my class, if I ask you a probability question and I don't see a fraction, immediately I don't grade it. It's wrong. It's got to start as a fraction. Now, that fraction can be turned into a decimal. Now, if you turn a probability into a decimal, it must be between 0 and 1. It must be between 0 and 1. Now, what does this mean? A probability of 0 is an impossible event. It will never occur, period. Okay? The example I like to use for those who have seen me in person, a probability of 0 would be, what is the probability that I shave my beard tomorrow? And the answer is 0. Never gonna happen, okay? A probability of 1 is absolutely certain to occur. It will happen. Nothing can stop it. What is the probability that the sun will come up tomorrow? It's 1. It's going to happen, okay? So that's an example of 0 probability and 1 probability. Now, most things in life are not certain to happen. Most things in life you can't say never, okay? You can't say they'll never happen. So almost everything else falls in the middle, 0.1, 0.2, 0.5, 0.8, okay? And the thing you need to know is that a higher number is more likely to occur, okay? A higher number is more likely to occur. So a probability of 0.8 is much more likely than a probability of 0.2, okay? So this is 80% chance it will occur if you think of a weather forecast, right? This is an 80% chance of rain, and this is a 20% chance of rain. One is much more likely than the other, okay? So there's our definition, and we're going to take some probability problems and see what we can do, okay? We're going to take some probability problems and see what we can do, and somehow I ended up with a stray mark on my paper, so we're just going to ignore that, okay? I don't know how I ended up with that stray mark on my paper. So here we go. And these are all going to be theoretical probability for the most part. We're going to run a few different ones, but most of these will be theoretical. So, what is the probability that a flipped coin lands on heads? So, the probability is always going to be a fraction. The question is, how many ways can this event occur? Well, there's only one head on a coin, so there's one way for that event to occur. The total number of outcomes, how many heads, how many faces, how many sides are on a coin? And the answer is 2. So the total number of outcomes will be 2. And that's your answer. 1/2. Okay, let's move on to a different one. What is the probability that a rolled die lands on the number 2? Well, it's a fraction. How many sides of this die have a 2 on them? And the answer is 1. A standard die has 6 sides. So the total number of possible outcomes would be 6. And that is your theoretical probability. Okay? Now, let's take the class that I'm teaching. A randomly selected person from this class is male. So this class has 33 members. The class has 33 members, and 12 are male. 12 are male. So we take our probability. How many ways can this occur? 12 ways. What are our total number of observations? 33. So 12 over 33. And as always in math, if a fraction can be reduced, you should reduce it. And so 12 over 33, and of course I hastily boxed it, but I know that 3 will go into both of these numbers, so this is actually 4 over 11. 4 over 11 would be our final answer. So this is your probability, and then you'd reduce it to 4 over 11. Okay? So let's look at cards. Okay, let's look at cards. In a deck of cards, there is a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. There are 4 suits: diamonds, hearts, spades, spade, not space, spade, and club. Okay? Diamonds, hearts, spades, and clubs. So, 4 suits. Every suit has a king. Every suit has a queen. Every suit has a 5. Okay? So there are 13 cards that are diamonds, 13 that are hearts, 13 that are spades, 13 that are clubs. Okay? And so if you know this information, I can ask you a bunch of questions about a deck of cards. So, one card is drawn at random. So this is the old magic trick. A guy fans out a deck of cards and says pick one card. Pick one card. Okay? So you pick one card, and we want to know the probability that that card is a king. So we're going to put, right, a fraction. How many ways can we pick a king? And the answer is 4. Why? Because there's a king of diamonds, a king of hearts, a king of spades, and a king of clubs. There are 4 kings in the deck. So there's 4 ways to draw a king. What is the total number of outcomes? Well, because there's 52 cards in the deck, the total number of outcomes is 52. So that's our answer, 4 over 52. However, 4 over 52 reduces to 1 over 13. So remember, reduce your fractions. Okay. What is the probability that that card, if we draw one random card, what is the probability that that card is a heart? Okay, well, we know there are 52 cards in the deck, so there are 52 total outcomes. How many of those outcomes are hearts? Well, there are 13 of each suit, which means there are 13 diamonds, there are 13 hearts, there are 13 spades, etc. So there are 13 hearts. So there are 13 ways to draw a heart. 13 out of 52. If we reduce this, we get a magic number of 1/4. And that number actually makes sense to me because hearts make up 1/4 of a deck of cards. Okay? So, on to the next one. What is the probability that this card, this one random card, is the ace of spades? Well, we know there are 52 total outcomes. There are 52 total outcomes because there are 52 cards in the deck. How many cards are the ace of spades? And the answer to that is 1. There is 1 ace of spades. So 1 over 52. Okay? Here we draw one random card. We want to know the probability that that one card is red. Again, there are 52 total outcomes. How many red cards are there? Well, if we remember, diamonds and hearts are both red, and spades and clubs are both black. So, diamonds are red, hearts are red. Well, there are 13 diamonds. There are 13 hearts for a total of 26 red cards. And if we reduce this fraction, we get 1/2. Again, that makes sense to me because half the deck is red. The other half is not. All right. So number 8, probability that you draw a 5 and an ace. Okay. So we know the bottom is 52. Do you see a pattern? Why? Because there are 52 cards in the deck. 52 total possible outcomes. Okay? And they want us to draw a 5 and an ace. And the probability of us doing that is 0. Now, if you're watching this video, you're saying that's not what I came up with. But you have to come up here and read the question. What does it say? 1 card is drawn. 1 card is drawn. What's the probability that you draw a 5 and an ace? If 1 card is drawn, it is impossible to draw a 5 and an ace, so that probability is 0. That is an impossible event. Okay? It's a trick question. All right. On to number 9. We know there's 52 because there's a pattern here. What is the probability that we draw 1 random card and that card is less than 5? Well, what is less than a 5? A 4, a 3, or a 2? Well, there are 4 4s, 4 3s, and 4 2s for a total of 12 cards. And so the top number, the number of ways I can make that statement come true, is 12 cards. I could draw a 4 or a 3 or a 2 and make that a true statement. A total of 12 possible ways to make that statement true. So 12 over 52, right? And we divide both of these by 4 and we get 3 over 13. 3 over 13 is what that reduces to. Okay? So let's do one more. So we're going to do one more here. Actually, we'll go ahead and do all of these because we've finished this up. Okay? So a jar has 25 green Skittles, 19 red Skittles, 13 purple Skittles, 17 yellow Skittles, and 26 orange Skittles. Now, the first thing I'm going to do is I'm going to sit down with my handy-dandy pocket brain, and I'm going to say 25 plus 19 plus 13 plus 17 plus 26. And I get 100 total Skittles. Okay? 100 total Skittles. Now, that's important because that's my total number of outcomes. So they ask us, what's the probability that we draw a red Skittle? We know the bottom number is 100. Why? Because there's 100 possible outcomes. How many of these Skittles are red? And the answer is what? 19. And 19 over 100 doesn't reduce, so that's our answer. Purple. Total number of outcomes is 100. Total number of ways to draw a purple Skittle would be 13. That doesn't reduce, so that's our answer. And then green, right? So green, what do we know? There are 100 possible outcomes. How many of those outcomes are green? 25 of them, so 25. This one does reduce. It reduces to 1 over 4, okay? And of course, any of these can be made into decimals. So the last one here, this is going to be not theoretical probability, but empirical probability, okay? So this is an insurance company, someone like that, picked up some data from somewhere. This could be census data, this could be anything. And they want us to ask some questions, okay? So, given the following data, a person is selected at random from this population. Find the probability that that person is a widow, okay? So, what is the total number of outcomes? Or another way to think of it is, how many ways can I select a person? What is our total data value? And the answer there is 221.8. 221.8. And these are in millions, of course. 221.8 million people in this data. Of that, how many of these people are meeting that criteria? how many of them are widows? And the answer, 16.2. And pretty much whenever we do empirical data, we're going to turn these into decimals. And the rule of thumb, it's not always the case for everybody, but the rule of thumb is to round to 4 decimal places. Okay, so in general, if someone asks you to find a probability and they ask for a decimal and they don't specify, the general rule of thumb is to round to 4 places. So I'm going to take my handy dandy pocket brain here and I'm going to type 16.2 divided by 221.8. Okay, and I get this number here. And I go 1, 2, 3, 4. I look to the right, I have a 3, so I'm going to round down. So my answer will be 0.0730. Okay, 0.0730. Or, as normal people look at this, you have about a 7.3% chance of selecting a widow at random. Okay? On to number 14. What is the probability that we select a random person from this population and we select a married man? So, our total number of outcomes is 221.8. 221.8. How many people fit that description? So I go to married. I can't pick this number. I have to pick this number. Why? That's how many married men are in my population. So 74.5. And I'll take 74.5 divided by 221.8. I'll show you my answer real quick. So my answer is, let's scoot it over here where everybody can see, is that 0.3358888 number. 4 decimal places, 1, 2, 3, 4. I look to the right of that as another 8, so I'm going to round that up to a 9. So my answer would be 0.3359, or in normal people terms, that's a 33.59% chance of selecting a married man from this population. Okay? Last but not least, what if I ask you, you're going to pick one person at random from this population, what's the probability that you get a divorced woman? Okay, so we know our bottom number will be 221.8. Why? Because we're picking from this total population. Okay, what's the probability that we pick a divorced woman? So we have to find how many people fit that description. How many people fit that description? So I go to divorced, and I look only at females. So divorced females is 15.8. So that's what we put, 15.8. That's the ways this event can occur. Okay? And we're going to divide that 15.8 divided by 221.8. And when I round this, I get 0.0712. Okay? So see if you get that same thing when you round. The digit after the 2 is a 3. And so because it's a 3, we round down, which means we leave it as a 2. Okay? So anyway, that is basic probability. That is basic probability, an introduction to probability, both theoretical and empirical. Theoretical probability will be things like skittles, spinners, cards, dice. Empirical probability will always be data. It'll be a table of data. It would be something you'd use if you worked at an insurance company. Okay? So if you have any questions about basic probability, shoot me an email or leave them in the comments.